So first of all, welcome to the Baltic. We are. You may or may not be aware. I wasn't here yesterday, but I don't know if it's been said. But this building actually is heated by waste heat from mines. In part, work done by Charlotte and Non maybe a decade or more ago, and that actually really helped drive adoption around UK of schemes like this. So this is a great piece of history that we're actually standing in for this. So let me see if I can. This. Right. UK heat demand. About 50% of all energy use in the UK is for heating buildings, and a lot of that is of course commercial, domestic. Some of that is also commercial, and there was a report into this that really kind of made the government aware of how much energy we do actually spend heating. And if we look at where the heat demand in UK is, actually, as you would probably expect, it is a function of population density. So larger population centres need more heat. The supply that we have, okay, where do we get our heat from? Well, most of it actually still today comes from natural gas boilers. So this is fairly recent data. This is 2024, 2025 data from Parliament. 75% of our heat energy comes from natural gas. Okay, 10%, approximately 9% comes from electric heating. A very small amount from renewables, oil and LPG, about 3%. That actually in the region that we're in now, Northumbria, Durham as well. There's quite a lot of rural households here that do not have connections to the gas grid, and you may have seen the news recently that the people are worried about the cost of because of what's going on in the Middle East, the cost of oil and gas going up. Of course, if you're on gas, you're sort of protected by this price promise thing, but a lot of the households in this area actually use oil for heating, and so are not being protected by that, and so the government's looking at how to help them. Heat pumps provide, well, probably now 1% of our heat. District heat networks, like we're in here, perhaps 2%. So the key thing is the thing that we have to look at is these natural gas boilers and oil and LPG. Those are the things that we now deem to be not so great for climate change. We're also not so great for energy security and price shock. So a couple of news articles here. One from the start of the Ukraine war, 2020. It's a long time ago, isn't it? 2022. We were still wearing COVID masks in shops, etc. when that started. So that shows you how long that war has been going on for. And that, of course, has caused record oil and gas prices. And then more recently, the war in the Middle East. So what are we doing about that? How can we in UK make our supply more secure? Well, the government did say that only 1% of the UK's gas supply comes from the Middle East, from Qatar, and that we don't need to worry. And they're not expecting it, and highlighted there, they're not expecting it to be significantly different from 2026 and beyond. Unfortunately, we are in this global situation, so price rises in one place will result in price rises in another. So we're not, even though a lot of the oil and gas we get comes from the North Sea, particularly Norwegian fields, we're not immune to those price increases. And it's also worth pointing out that within the next 10 years or so, the Norwegian fields are going to be severely depleted, and so we have to find other sources for our gas. If we look at our temporal heat demand, you can see, as expected, it goes up a lot during the winter. Quite why? Who's heating their house in the summer? I'm not quite sure. But anyway, it must be other sources of heat, hospitals, for example, industry, and so on. But yeah, so we've got this base load all year round, but a significant increase in supply during the summer. If you correlate that with our electrical demand, again, electricity increasing slightly in the winter. That will be partly the heating, more lighting, etc. If you look at the electricity we get from low carbon sources, that's essentially flat all year round. And I think that that's because solar, of course, peaks in the summer, but that's balanced by the winter being more windy. Now, so this looks like it's going to be a problem. We've got all this heating that we need to be doing, but it's all coming from places where we don't really want to get it, and we need to look at how we're going to change that. What are we going to do about our heat in the future? Well, if we look at our waste heat, unexploited heat, what we're doing. Well, this is data from I think 2022. Says that somewhere. Yeah, 2022. So we started looking at doing some freedom of information requests and trying to calculate how much waste heat there is in the UK. Now, many companies refuse to disclose that because it's commercially sensitive information. But this map, again, there shows kind of the density of waste heat, where these waste heat sources are. And it's not a complete picture, but it's probably fairly reasonable. And if we look at underground storage of waste heat, areas that we can do that in, we've got aquifers on the left-hand side. So a lot of the UK has aquifers that could potentially be used for storing this waste heat, and then the mined areas on the right-hand side outlined there in black. Again, those correlate quite well with our demand for heating. A lot of that is well correlated with the population centres, but also with these aquifers and with these mined areas. So you might think, well, okay, there's a lot of potential that we could use here for making use of waste heat, storing it and reusing it. Next thing that we can look at is data centre distribution. So March 2026, from some source, by some definition, UK had 511 data centres. I did dig into that slightly and discover that the data centre that we run at Durham University is not included in this. So I think this is probably just commercial data centres offering cloud services. So there are actually more data centres than that. As with operational and planned status, the average power usage of those data centres is 5.7 megawatts. That's an interesting figure. I suspect massively skewed by a small number of very high powered data centers, say at the 100 megawatt or gigawatt level. Most of these data centers are most likely a lot smaller, up to say 1 megawatt. So for example, the Durham University data center is just over 1 megawatt capacity, and that certainly for universities until fairly recently, that was considered quite a large capacity. So a lot of these data centers are probably going to be less than a megawatt, but there'll be some that are at the 100 megawatts, even starting to think about gigawatt scale data centers. But if you average all that out, you could probably come to this average 5.7 megawatts. National heat output, 25.5 terawatt hours. And so therefore, this waste heat, probably 5 to 6% of UK heat demand. So we could quite easily, if we were able to make use of that, reduce what we actually need to generate for heat by some fairly not insignificant fraction. A lot of data centres clustered around population centres, as you see a lot in London, Manchester, Leeds, West Yorkshire, and so on. So this is the rise of the data centre. This is a data centre, proposed data centre at Akeley Heads in Durham. So January 2025, we were granted planning permission by the council for a new data centre. Now, this is an interesting story. This data centre, there's some reasonable chance this data centre will never get built. So if you don't like data centres, you probably don't need to worry too much. It was funded by the previous government. They told us we were getting funding to build a data centre, and they were about to announce it when a general election was called, and that meant that they could make no more announcements. So then this kind of sat on the back burner, waiting for the change of government, and then the new government decided there wasn't enough money, and so they cancelled the data centre. But at the time, all the plans were going in for this new data centre. So we went ahead and got planning permission and designs for it anyway. So it may or may not happen. We've had no sign since that it's going to happen. But if it did, it would be a very good opportunity to be making use of the waste heat. And this is something that we'll talk that comes, I think, in the next slide. one of the things that we want to look at is kind of what you can do with cooling solutions for data centers, whether you can up the waste heat temperature by immersing servers, for example, in oil rather than having them in air and using water for cooling. You can drive the temperatures up, which then makes the waste heat much more useful. And that also makes it more attractive for storing that heat as well. And more about that in my talk later on. So if we think about the economics, the maths behind this, one data center, 5.7 megawatts, average 50 gigawatt hours of waste heat annually. The average UK house, let's say, is about 11 to 12 megawatt hours of heat requirement annually. So therefore, one data center could heat about 4,000 homes. If you think about heating only being needed, say, in the winter, then that might be 2,000 homes. You've got waste heat that you need to deal with in the summer, but perhaps you can store that with some efficiency and heat a few more homes during the winter when it's needed. So aquifer thermal energy storage systems, typically that was an acronym that I had to learn, typically have high storage efficiency. That seems pretty good, actually, 70 to 80% of energy recovered. So there you go. You could probably heat with a data center between 3,000 to 4,000 homes, depending on this efficiency. The map here, that's just showing parts of Manchester. We've got another map here, which is showing the middle of Durham. The Akeley Head site outlined there. The grid, you can see at the very top. Pointer, no pointer. The top right there, Durham Constabulary headquarters. There's a field to the left of it, another field to the bowling, an old bowling green to, I think, was it tennis court to the left of that. That was where the data center was gonna sit. And you can see there's a lot of buildings around there. The hospital up to the left, the police headquarters, council buildings, the Akeley Heads development area that could make use of waste heat. So, and hospitals are a very good one because they need heating the buildings all year round. So that had a lot of potential. So again, mapping where data centers are to where storage areas are, you can see they all fit quite nicely. Areas where you've got mines that you can use, that's great. A lot of these areas also have aquifers that you can use. In terms of energy security, balance of payments, sustainability, etc. Well, where does our gas come from? UK, Norwegian gas field, 75% at the moment. Imports, which now of course the imports of liquefied gas are much higher carbon. This plot on the right here shows on the x-axis, the bottom axis, the width of the bars, how much what percentage of our gas comes in, and then the going up shows the carbon intensity of that gas. So the Norwegian gas and UK domestic gas are pretty good. As those fields start to empty and we have to import more liquefied gas, that becomes much higher carbon intensity, much worse for climate change, etc. And so really what we want to be looking at doing is reducing our gas. Even though gas is far better than, say, things like oil and coal in terms of climate change, we still need to massively be reducing that. So the conclusions are, we've got this big push coming for new data centers. This offers us the opportunity to deliver waste heat to 2 million homes or more, heat for people, if we get our planning, if we get our design, if we get our building right, and funding, I guess, for retrofitting, etc. We want to be using the mines, the flooded mines we've got, aquifer thermal energy systems, reducing our demand for heating and gas. New heating can reduce our gas by 6%. We can reduce our emissions balance from gas combustion by more than that, because we will displace we can displace the liquefied contents from the Middle East, which are much higher carbon, whilst maintaining, certainly in the near future, the lower carbon imports we have, well, not imports, the stuff we generate in the North Sea. So I hope that all made sense. Thank you for listening. Apparently this is no longer under copyright, so John's happy to use it. So anyway, there you go.